Alright, now we're going to plug the function and its second derivative into the left-hand side of the non-homogeneous differential equation and set that equal to sine of 2x and figure out what a and b are. So we have second derivative so plugging yp and yp double prime into the non-homogeneous equation, we have, let's see, second derivative minus, we have a total of minus 4a sine 2x, minus 4a sine 2x plus 4b cosine 2x minus 4bx sine 2x minus 4ax cosine 2x. Alright, that's the whole second derivative. Y double prime plus 4y. So plus 4y is plus 4ax cosine 2x and plus 4bx sine 2x. All of that added together should be equal to sine 2x. Sine 2x plus 0 cosine 2x plus 0x sine 2x plus 0 cosine x, 0x cosine x, sorry, cosine 2x. I'm writing the zeros here just because the only thing we have on the right hand side is the sine x. We don't have any cosine x, we don't have any x sine x, we don't have any x cosine 2x. So now minus 4b plus 4b is 0, so that's taken care of. Minus 4a plus 4a is 0, that's taken care of. 4b has to be equal to 0, so that means b equals 0. Minus 4a equals 1. So that means a equals negative 1/4. A equals negative 1/4, b equals 0. So this particular solution is just going to have a cosine term. So we have negative 4a equals 1, 4b equals 0. So that means that a equals negative 1/4, b equals 0, and yp equals, I just erased it, but it was a cosine 2x. So negative 1/4 cosine 2x plus 0 sine 2x. So then all solutions of the non-homogeneous system, the non-homogeneous differential equation, are y equals negative 1/4 cosine 2x plus any multiple of cosine 2x without an x here. Oops, this should be x minus 1/4 x cosine 2x. Plus any multiple of just regular cosine 2x plus any multiple of regular sine 2x, or c1 and c2, or any real numbers. Alright, and then a natural next question. If we're given an infinite family of differential equations, often the next thing we ask is which one of those differential equations, which one of those solutions, we have an infinite family of solutions, which one of those solutions has certain properties. And that type of question is called an initial value problem. So which of these solutions satisfies y of 0 equals 3, y prime of 0 equals 7/4. Now y of 0 being equal to 3 means that 3 is equal to, when we plug in x equals 0, this is 0. And we've got c1 cosine of 0. So 0 plus c1 cosine of 0 plus c2 sine of 0. Sine of 0 is 0. Cosine of 0 is 1. So 3 equals c1. All right, now for y prime of 0 to be equal 7/4, I guess we need to differentiate so we have an expression for y prime of x. So y prime of x equals, product rule here, negative 1/4 derivative of the first times the second cosine of 2x plus derivative of the second minus 2 sine 2x times the first. So make that a plus, divide by 4. Derivative of the first times the second plus derivative of the second times the first. Okay, I guess we're done. And then derivative of this is minus 2 c1 sine of 2x. And derivative of this is plus c2 plus 2c2 cosine of 2x. All right, now we can plug 0 into that. Y prime of 0 being equal to 7/4 implies that 7/4 equals negative 1/4 cosine of 0 plus 1/2 sine of 0, that's just 0, minus 2c1 sine of 0, that's 0, and then plus 2ct cosine of 0, plus 2c2 cosine of 0. So 7/4 equals minus 1/4 times 1 plus 2c2 times 1, which means that if we add 1/4 to both sides, 8/4, 2 equals 2c2, which means that c2 equals 1. That means that the solution we want is C1 all right, C1 is the coefficient of cosine, and C1 is 3 cosine of 2x. C2 is the coefficient of sine, plus sine 2x plus this particular solution part of it, minus 1/4 x cosine of 2x. The end.